the following system functions using a minimum number of multipliers. In these three subcategories, the first problem is h of z equal to 1 plus 2z power minus 1 plus 3z power minus 2 plus 4z power minus 3 plus 3z power minus 4 plus 2z power minus 5 plus z power minus 6. So this is the given problem. In this kind of problems, why they are mentioning minimum number of multipliers means normally we will implement, otherwise we will realize the functions, but more number of multipliers will be using. In order to avoid that, we are going for this structure. So when compared to traditional realization, we will be using less number of multipliers. So only this method is preferred. Let us see how. If you see the h of z, the coefficients will be repeated. For example, in this h of z, totally 7 coefficients are there. If you find the center point, it is 4z power minus 3. So the 4z power minus 3 point, the left hand side point and the right hand side point will be the same. If you see, the coefficient of the left hand side is 3, that is 3z power minus 2. Similarly, the right side to the 4z power minus 3 is 3z power minus 4. Similarly, the second left is 2z power minus 1. Similarly, the second right is 2z power minus 5. And similarly, the third leftmost is the 1 coefficient and the third rightmost is the 1z power minus 6. So by using this relation, we are going to use the less number of multipliers. So how? So totally in this expression, if you see, 6 delay elements are there. Z power minus 6 is the maximum delay element we can see. So in our realization structure, 6 times the delay elements will be used. And if you see the h of z, we can write it as y of z by x of z. Therefore, this can be written as y of z divided by x of z equal to the same term. So y of z alone, if we retain in this side, so y of z equal to 1 plus z power minus 6 into x of z, that is coefficient terms, this one and this last term. Similarly, plus 2 into z power minus 1 plus z power minus 5 into x of z plus 3 into z power minus 2 plus z power minus 4 into x of z plus the center term, that is 4 z power minus 3 into x of z. Okay, so this term only we are going to implement. So for that, first we have to mark this x of z here. Then we have to mark the what delay elements. For example, this z power minus 1 and z power minus 1, like that delay element we have to make it. So if you see this one, you can see this z power minus 1, we can have z power minus 1. Similarly, another z power minus 1 and z power minus 1. Likewise, this z power minus 1, this z power minus 1 and this z power minus 1. So that we will be having 1, 2, 3, 4, 5, 6 delay elements. Then we have to join from x of z to this one, and this delay element to this one, and this delay element to this one, and similarly this delay element to this one, and similarly joining all these two. Okay, then we have to mark the coefficients. If you see here it will be x of z. At this place, here it will be z power minus 1 because the delayed element. And similarly, here it is z power minus 1, but at the same time, here it will be z power minus 2. Here it will be minus 2, here it will be minus 3, then here it is minus 3, here it will be minus 4, and similarly z power minus 5, z power minus 6. So like that the delay elements are arranged. Now if you see x of z into 1 plus z power minus 6. So 1 plus z power minus 6, this has to be combined. So z power minus 1 here, minus 2, minus 3, minus 4, minus 5, here minus 6 will come. So this z power minus 6 will be given to this adder, and 1 without delay element, that is also given to this adder, and the added result is given to this 1, that is the coefficient 1. And similarly next one, if you see z power minus 1 plus z power minus 5, z power minus 1 is here, so take it to this adder. So z power minus 1, minus 2, minus 3, minus 4, minus 5. So here it will be minus 5. So this I am going to give it to this adder, so that these 2 points I will be drawing here. Then the coefficient is 2 here. So the coefficient 2 I have drawn, I have put here. Similarly, z power minus 2 plus z power minus 4. So here it will be z power minus 2, z power minus 3, here it will be minus 4. So z power minus 4 I have drawn here. So these are given into the adder, and the coefficient is 3 here. So the 3 I have marked here. And finally, z power minus 3 is left here. So this is z power minus 3 into 4. So that coefficient I have added here. So all this output I am making from the adder to this adder. So all these are added and given to the y of z. So that is what this y of z. So this is what the minimum number of multipliers.